The next type of bonding that we're going to talk about is metallic bonding, and it's the, you haven't even heard me mention it before. It's an interesting type of bonding. It happens obviously within metals. Basically what happens in metallic bonding is this: the valence electrons of metal atoms can be modeled as a sea of electrons. So they're kind of moving around the outside of the atom. Okay, so because there's very few, because all metals will only have a few valence electrons. It's not like your non-metals where there might be 6 valence electrons or 7 because they're on the far right side of the periodic table. The metals are going to be on their left side, which would only have 1 or 2. So they're mobile, they drift freely around one another. And so these bonds consist of attractions of these free floating valence electrons for the positively charged metal ions. They are forces that hold metals together. So metallic bonding is kind of like forces. So if you have an aluminum, a chunk of aluminum, all the aluminum atoms have these free floating valence electrons, and they kind of attract to each other. And they form this what's called metallic bonding. I've got a couple of definitions here because it sometimes can be a little confusing, and I'm perfectly fine using this Wikipedia. Notice it just basically says here that the reaction, there we go, within metals are called alkali reactive force. It's the sharing of free electrons, okay, and it forms this lattice, so like this connection of metal atoms. What's nice about this is it allows them to be very pliable, to be very ductile, okay. When you try to hammer or to bend an ionic compound, it's going to shatter, it's going to break, it's going to cleave. Metallic bonded substances allow them to bend. You can hammer a sheet of lead and it'll flatten right out without shattering. So that's kind of the valence of the electron. It talks about how the electrons move independently of the positive ions in the sea of a negative charge. Not a bad little definition. I also kind of like this one as well. I just threw this one up here as well. This is on the NDT Ed Resource Center. And it talks about how this contains only 1 to 3 electrons in the outer shell. So as you can see right here, there might be 3 electrons. And so it's kind of this electron cloud. So what happens is as they get together, here's your nuclei, these valence electrons kind of get attracted to each other. And it forms this metallic bond that becomes this, again, allows for this sliding past each other when it's deformed instead of fracturing like other metal things. Some common features: good electrical or thermal conductors due to those free valence electrons, usually opaque, and relatively ductile. Ductile can be stretched into wires. So this is your metallic bonding. I do want to go a little bit further. They're always arranged in these compact, orderly patterns. You've seen me talking about that. And also the term alloys. Alloys are when more than one metal get together to form a mixture. And so it's a mixture of 2 or more elements, at least 1 metal, usually 2 metals. An example: brass, copper, and zinc get together to form brass. Usually it's melted down copper, melted down zinc, and then you put them together and they will alloy and form brass. Same thing with bronze, copper, and tin getting together. There are so many other metal, alloys: stainless steel, gold is, if it's not 24 karat gold, if you have 14 karat gold, obviously it's gold alloyed with other metals. These things will be stronger. When you have alloys, they're stronger than the original. So brass, bronze, both stronger than the components, and that's because when they do form these alloys, there's a linkage, there's that lattice formed that we were just talking about. 14 karat gold, 18 karat gold is stronger than 24 karat gold. 24 karat gold, if you have a necklace of 24 karat gold, first of all, good for you. But secondly, that's going to be very, very ductile. It'll get stretched. If you put a charm on that necklace, it'll stretch. Versus a 14 karat gold chain, it's a lot stronger because it's been alloyed. So that's metallic bonding.